Hello students and welcome to third video on solid state. In my last two videos, I have explained you about some of the topics from solid state. In the first video, I had discussed about introduction to solid state, types of solid, their properties, isomorphism, polymorphism, then crystalline solid and their properties. Then in the second video, I explained you about crystal structure, unit cell, types of unit cell and Bravais lattices. Now, in this third video, we are going to discuss about the following points. First, number of particles in each type of unit cell. Second, type of arrangement in different dimensions. And third, voids and its types. First, number of particles in unit cell and its coordination. Number. First one is SCC or primitive unit cell. Now we know that in an SCC or primitive unit cell, there are particles present only at the corners in a three-dimensional structure. So when this unit cell is used to make a large crystal, then we will see that the 8 corners of the cube will come in contact with 8 more crystals, due to which the share of each unit cell will be equal to 1/8 of 8, that is equal to 1. Therefore, number of particles in SCC or simple cubic crystal is equal to Z is equal to 1. And coordination number. Now what do you mean by coordination number? So coordination number represent the number of particles that are in contact with the given particle. Now say for example, you're sitting in a classroom and in a row you're sitting on the third bench. Now there are 3 students sitting in front of you, 3 students sitting next to you and 2 students sitting besides you. So in that case, your coordination number will be equal to 8 because you are in contact with 8 people, 3 in front of you, 3 behind you and 2 on your left and right side respectively. So here the coordination number of SCC is equal to 6 because each particle in SCC comes in contact with 6 different particles. Second one is BCC unit cell. Now in BCC unit cell, we know that there are particles at the corners as well as there is particle in the center of the cube. Now if the particle is present at the corner, then we know that its share will be equal to 1/8 into 8, which is equals to 1, and the particle which is present in the center of the cube will not come in contact with any other particle. Therefore its contribution will be the whole 1, and therefore the particle at the center will have its value as 1. Therefore total number of particles will be equal to 1/8 into 8, which is coming from the corners, as well as 1 which is coming from the center of the cube. Therefore there are total number of 2 particles in BCC. Then its coordination number. So the coordination number in BCC is equal to 8. Third one is FCC or face centered cubic cell. Now here we know that particles are present at the corners as well as one particle is present in the center of each faces. So in total there are 6 particles at 6 faces. Now we know that contribution of the particles at the corners equal to 1/8 into 8, which is equals to 1, and the particle which is present at the face will come in contact with one more particle. Just imagine that you are holding 2 cubes and these 2 cubes are placed besides one another. So you will find that one face of the cube will come in contact with another face. So the share of each face will be equal to half. But there are total 6 faces, so half of 6 will be equal to 3. Therefore total number of particles will be equal to 1/8 into 8, which is coming from the corners, and half into 6, which is coming from the faces. So we get total number of particles is equals to 3 plus 1, which is equals to 4. And coordination number in FCC is equal to 12. Fourth one is base centered unit cell, or we also call it as end centered unit cell. Here we know that particles are present at the corners as well as particles are present at the ends, that is at the top and at the bottom. So Contribution from the corners will be equal to 1 upon 8 into 8, which is equals to 1, and contribution from the top and the bottom portion will be equal to half into 2, because we know that the particle at the top and base is present on the face, so it will come in contact with one more cube, and therefore its contribution will be half. And like this, there are two particles, one at the top, one at the bottom, therefore it will be half of 2, which is equals to 1. So total number of particles will be equal to 1 upon 8 into 8 coming from the corners, and half of 2 coming from the top and the bottom faces, which will be equal to 1 plus 1, which is equals to 2. Next is void, types of packings in different dimensions. Now, first one is packing in one dimension. Now, this type of packing represents particles that are present in a straight line, that is either horizontally or either vertically. As you can see in this diagram over here, it can either be placed vertically one besides the other, or it can also be placed horizontally one besides the other. Second one is particles in two dimension. Now over here, the particles are arranged vertically as well as horizontally at the same time. Means particle is placed one beside the other in a straight line, vertically as well as horizontally. You can see from this figure over here, the particles are placed horizontally as well as they are placed vertically. Now this type of arrangement has got two different kinds. One is square planar placing and second one is hexagonal placing. Now when you talk about square planar placing, you will find that the particles are arranged in a regular pattern, exactly one below the other, one below the other. And if I take any four particles and if I join their centers, you will find that this centers which I have joined will form a square. At the same time, the second arrangement, which is also called as hexagonal close packing, here 6 spheres are in contact with each other, and if I join the centers of these 6 spheres, it will form a regular hexagon. Therefore, it is called as hexagonal close packing. Then next one is packing in 3 dimension. Now over here, the particles are arranged along the length, breadth as well as along the height, that is along the 3 axes x, y and z. Now here you can see, if I see the first face, then that first face will represent 2 dimension, that is having length and breadth. But when I add third dimension to it, that is when I add height to it, so it will form a cube. So this kind of arrangement is called as arrangement in 3 dimension. It is also applicable for square planar as well as for hexagonal arrangement. Next is voids and its types. So voids in simple words means empty space that is found in a crystal. Empty space that is found in a crystal is called as a void. Now there are two types of voids. One is tetrahedral void and second one is octahedral void. Now let us discuss about these two types of voids in detail. When you say tetrahedral void, so I want you to just imagine, say for example you are having 3 circular plates. Place those 3 circular plates such that they are in contact with each other, as you can see in the figure over here, the second figure where 3 blue color circles are there. So just place those 3 plates like those 3 circular circles over there. You will find that wherever these 3 plates meet, you will find some empty space over there. Now place the fourth plate exactly on the center. As you can see in the second figure, orange color circle is being placed on that 3 blue color circle over there. So such kind of arrangement gives rise to a tetrahedral void. Now why it is called as a tetrahedral void? So it is called as a tetrahedral void because there are 4 spheres involved, and if I join the center of these 4 spheres, it will form a regular tetrahedron. As you can see in the third figure over here, it forms a regular tetrahedron. Therefore the name is given over here as tetrahedral void. Next one is octahedral void. Okay, before going to octahedral void, the coordination number over here of each particle is equal to 4. Next one is octahedral void. Now in octahedral void, we are going to take total 6 spheres such that 3 spheres are in one layer and next 3 spheres are in the second layer, but in inverted direction. Now here you can see the second figure, the B figure over here. The orange color circles are in one direction and the blue color circles are in other direction. And when I place these orange color circles on blue color circle, I'll find some empty space at the center, which can be seen in figure A. So this kind of void that is produced by total 6 spheres is called as a octahedral void. Again, why it is called as octahedral void? Because if I join the centers of all these 6 spheres, I'll get a regular octahedron, as you can see in the figure C. That is why it is called as octahedral void. Now here the coordination number of each particle is equal to 6. Now, in order to summarize these two types of voids, very important question, let us try to understand them in the form of a distinguish comparison. First, tetrahedral void, it is formed when one sphere is placed over 3 spheres in another layer, whereas octahedral void is formed when 3 spheres in one layer is placed over 3 spheres in second layer but in opposite direction. Then for the formation of tetrahedral void, we require 4 spheres, whereas in the formation of octahedral void, we require total 6 spheres. Then if we join the centers of the 4 spheres, the shape formed over there represents a tetrahedron, whereas in octahedral void, if we join the centers of the 6 spheres, the figure that is formed over there is an octahedron. Then coordination number of tetrahedral void is 4, whereas coordination number of octahedral void is 6. And the fifth point, which is very important, which will be useful in the coming lectures to solve certain kind of numericals. Listen very carefully. If there are n number of particles, then the total number of tetrahedral void will be equal to 2 times n or 2n, whereas if there are n number of particles, then the number of octahedral voids will be equal to n. Now, this statement which I am giving over here will be applicable in the coming videos to solve certain kind of numericals. So remember this point and remember this distinguish, very important from your exam point of view. So from this video, I have given some important questions. First one, what are voids? Then distinguish between octahedral and tetrahedral void. And two fill in the blank type of questions. The number of particles in BCC is dash. The coordination number of FCC is dash. Thank you for watching this video, and if you have liked this video, please give me credit by liking it, by sharing it with your friends, and by subscribing to this channel so that you keep on getting regular updates about the new videos. Also, don't forget to press the bell icon to get the regular updates. Thank you.